What's going on, everybody? It's Mike from Dungeons and Diving, and we're back again with another reverse engineering tutorial. Last time we started with a small binary from Pico CTF. Today we're going to start with a little bit bigger of a game that I wrote in both C and C++, same game. And then also compiled it both for Windows and for Linux, just so we can explore them as time goes along with this tutorial series. Today, to make it easy, we're going to start with the C version of the game, compiled for Linux, because there's a lot less C runtime stuff being built into it. Since I'm on a Windows machine, I do need to run the Windows version of it, but that's super simple because it is the same exact thing, and the only reason we're going to run it is just to see the operation of the game a little bit. So I'm going to run cgame.exe. It starts off with, do you want to play a game? Typically, no, I don't want to play a game for somebody that I don't know what it is. And I click no, bring me a bucket, and I'll show you a bucket. All right, let's run it again. What happens if I put a bunch of characters in there? Oh, cheating detected. Penalties will be applied. Run it again. Okay, so my options right now, I click no. I put some stuff that it doesn't expect. I'm going to click yes. Welcome to your doom. It's dangerous to go along. Take this with you and enter Master Sword into the terminal. Okay, let's do what it says. Master Sword. What happens if I type in Master Sword? Alert, wrong answer detected. Please consult the nearest tutorial for assistance. All right, so it's playing some games with us. Just for some honesty here, it will not give you the correct flag to capture. So the whole point of this is to force somebody to get the correct flag in order to actually win. All right, so let's move on into Ghidra. Again, all you have to do is just drag and drop it. Cgame Linux, it'll pop up with a import statement. Double click on it, run the analysis on it. As soon as that is done, again, the first thing that I typically run to is I run to main. Oh my gosh, look at our decompiler window on the right hand side. There is so much stuff in here. Hey, look, we've seen the cheating detected, penalties will be applied. Do you want to play a game? Welcome to your doom. Bring me a bucket. Another cheating detected. There's a whole bunch of stuff in here. And yes, that's in there just to force you to do some reverse engineering. That is the whole point on why I built it this way. What we can do is we can go look at the graph view. Okay, so you go up to the top menu. You can look at the block flow. Ghidra will do some stuff, and oh, hey, look, there's a whole bunch of different things. That doesn't mean anything to me. What these are the different addresses of the instructions you can see right here. I'm going to close this window out. We're going to look at the code flow. And if you look, this is a little bit more helpful to us. If you look, it does move EAX 0, so it's zeroing out EAX, and then it's calling this function. If you look, that's because I called that right there. A little helpful, not really quite that much. We can look at the calls. And then you can see main, it doesn't know where to go for main. So let's scroll all the way back up to main, right? Let's try and run this one more time. Ah, hey, look. Now that I'm in here, you can see that it's calling about a couple different functions. It's going to call function A. It calls some stuff for C types. We're not going to worry about that. It's going to call the toLower function, puts, fgets, and then there's a check fail there. But again, that's not something that we're going to use on this one right here. Those are things built into the system. So we're going to look at the things that are actually important to us. So we look here, main only really calls, so the toLower function, what that's going to do is that's going to go and it's going to take a string and it's going to output it into lowercase. It's not a big deal, and it's not the functionality we're going to look for. However, it's important when I do this for comparisons for strings. So we're looking at a bunch of these things, and nothing really seems to stick out down here. Inputs, these are all a bunch of things that are built into the C library. But this function A, right? So this function A, we want to see what is that. So we're going to go and right-click on it, references, and show references to function A. And we can see in here, we call function A here. If you look here, it's highlighted over here. So if character local 78 is equal to Y, so this is in C, that's going to grab the first character of a string. Then it puts welcome to your doom. So when I started the program and I said, yes, I want to play a game, that's what this variable was. So it accepted Y. It accepted a bunch of characters, but it only compared the first one. And if you look here, here's that toLower function. It's going to take that first character from the input of that string that we put. It's going to put it into toLower, and then store it in this ivar1. The reason for that is because instead of having to write a check for lowercase y or uppercase y and calling the same thing, I passed it a single lowercase value that I'm able to check just for the lowercase y in order to proceed. Now, we're going to move into this function a, since this is the one that probably has our fun stuff. You know, that if you look down here, if it was equal to n, it was bring me a bucket and I'll show you a bucket. And then if it's anything other than a y or an n, cheating detected. Hey, we saw all of that. All right, so with that said, we're going to move into this function a that we noticed on the graph that it kind of stuck out. There was no debugging information. We didn't know what it was, so it probably didn't come from the standard library. So we'll move over into function a, and we got some cool stuff in here. Hey, look, there's quite a bit in here. But if you look on the right-hand side, again, look at the decompiler window, and Ghidra will try and help us out here. So we see it's dangerous to go alone. Take this with you and enter master sword into the terminal. Oh, hey, look, we saw that on the terminal. What is it doing? It's just printing that out for us. So we followed along with this master sword business, but obviously that wasn't the correct answer. So then it's going to use fgets to take in 100 characters from stdin. It's going to store it to local 78. Then what we need to do is we move along, and then we see that there is another, oh, hey, look, there's a function called to endgame. I wonder what that might be. So we double click on that. It takes us into this other function here. So when we start this function here, we look along, there's another couple calls. There's a string compare, there's a call to puts, another call to puts. So look on the right hand side, we have a string compare that says I used to be an adventurer like you until I took an arrow to the knee. Interesting, we didn't see that one. We also see a put statement for does your back hurt from carrying this RE challenge so hard? That could be a hint. And then we see alert, wrong answer detected. We did see that when we entered master sword. So in this case right here, we do want to see this, does your back hurt from carrying this RE challenge so hard? Yes, that is the print statement for actually solving this challenge. So in order to do that, we need to get into this. So if var1, ivar1 is equal to 0, it's going to be up here. Ivar1 is the return statement from string compare. String compare will take in parameter 1 and parameter 2, and if they are equal, it will output a 0. So for us, we're going to look at this right here, and we want parameter 1, which is passed into endgame. That is the input from the player. We want parameter 1 to be equal to this right here. So let's go ahead and copy this, including the period, because it is inside of the quotation marks. We want to copy that. And then that should get us to this does your back hurt from carrying this RE challenge so hard. We'll go back to our window here. Let's play the game one more time. Do we want to play the game? Yes. Welcome to your doom. It's dangerous to go alone. Take this with you and enter master sword into the terminal. Paste that in there. Does your back hurt from carrying this RE challenge so hard? Now we have solved our challenge. Now, there are a couple shortcuts that if you are interested in looking at this in a much quicker pace, you can use this same search method. But this time, instead of searching for program text, I don't have a Pico CTF here. So in order to search for text that might lead us in the right direction, you know, the wrong answer right here where it says wrong answer detected, that would be a huge clue for me. However, I don't know what that's going to say unless I actually walk through this process. A quick shortcut to help us figure out where to go is we can look in the search menu and you go down for search strings. You can have a minimum length. I'm going to leave it at 5. That's probably not a bad idea. You can search for all blocks or just what's loaded. I'm going to click on all blocks. Again, this is not that big of a program, so we might as well do everything. And we're going to search everything. All right, so that generated a huge list of strings for us. If you can look, there's GNU versions, data comments. Again, those are not things that are going to be related to our program, but rather the things that are compiled into it. String compare, fgets. These are different function calls and addresses. Again, not things that we really worry about. What we're going to do is we're going to scroll down to the bottom, and you can see there is a huge stack of strings that I compiled into this program, with the exception of this guy right here. So there's a byte sequence that Ghidra thought might be a string, and it's going to give you the false positives at times, because a false positive is better than missing out on some of the strings that you're looking for. So what we're looking for, you have your do you want to play a game? You're welcome to your doom. When you click no, bring me a bucket, I'll show you a bucket. If you enter something wrong in there, either not a yes or no to that question, or some funny business later on, you get this cheating detected. But again, if you look right here, we have the wrong answer detected, and we see the flag is right here. I used to be an adventurer like you until I took an arrow to the knee. That is the correct flag. We don't know that that's the flag, but when we're looking at these strings, we can see right here, wrong answer detected. Oh, hey, that might be an interesting point in the code. So I can go ahead and I can double click on it, minimize my code here, and if you look, it brings me to the section that actually stores it. I can right click on it, I can go to references, and then show references to address. And if you look, there's only one location that references this address, and it is an LEA-RDI with that pointer, and that's going to call it to puts. If you have a program that has a lot of functions, this may save you time so you don't have to reverse engineer every single function, but it might take you to the point of interest where these strings are being used. So in this case, if we would have started with that, we would have gone right here to wrong answer detected, and then we could have seen, oh, hey, look, this might be the answer. So it could be a quick way to test various strings that you find in these capture the flags, or it might lead you, for a different type of project, it might lead you to a section of code that is more interesting in a relatively shorter period of time. Now that we've walked through the assembly code and we've found the actual key phrase I was looking for, we've also walked through the shortcut on how to find these based on strings or other things that may be related to the section of code that we're looking for. We're going to go ahead and wrap this video up. Thank you for watching. Happy hacking.